Hello everyone, welcome back to our channel Alchemist. Today we are going to see the concept acids, bases and salts. Let's get into the video. The first topic is introduction of acids, bases and salts. Okay, the first one is classification. See this picture. What is the first thing that comes to your mind when you see this? The first one is watermelon. It is sweet in taste, okay? And the next one is potato chips. It is salty. And the third one is lemon. It is sour. And then the fourth one is beetroot. It is bitter in taste, okay? The first thing that comes to our mind is taste, okay? Years back, scientists in Greece, they classified the things based on taste, okay? The first one is acids. See this picture, the tomato, the lemon, that is the citrus fruits like lemon, orange, etc. And cheese are sour in taste, okay? And acid comes from the Latin word acidus, meaning sour, okay? The sour tasting things have similar chemical properties, okay? And some of the naturally occurring compounds containing acids are tomatoes, as we already seen in this picture, tomatoes, and then vinegar, and then sour milk, and then gastric juice, and citrus fruits like oranges and lemons. See this picture, lemon is a acid base substances, and then grapes, tamarind, apple, etc. Okay, let's see the acid's nature. When we intake acids in the form of fruits like tomatoes, tamarind, etc., it did not harm us. But in labs, we use the pure concentrated form of acids. Okay, that pure form of acids are corrosive in nature. Okay, while handling pure acids, one should be very careful. They should be very precautionary. They should wear goggles, gloves, and lab coats, etc. for their precaution. These are the precautionary measures. And next one is bases. Bases are bitter in taste, okay? Or otherwise the word is slippery, okay? And the examples are mustard oil and then soap. Soap is the best example for bases, okay? And in aqueous solution, we see what happens when in salt, that is NaCl, reacts in aqueous solution. Okay, some substances when dissolved in aqueous solution forms ions, okay, as we know. Okay, let us dissolve NaCl in aqueous solution. That aqueous solution means we have to dissolve the NaCl in water and it form ions, that is Na plus and Cl minus. Okay, this is a basic concept we have to know. And then the next one is Arrhenius concept. Okay, Arrhenius classified acids as H plus ions. Okay, and these are the only positive ion in solution. Okay, and see this H plus is not as stable. Okay, when it reacts with water, it forms hydronium ion, that is H3O plus. When a substance containing H3O plus, it is termed as acids. Okay, the basic definition for acids is it contains H plus or H3O plus ions in solution. Okay, the first example we are going to see is the HCl. HCl dissociates as H plus and Cl minus, okay? And when it reacts with water, it forms hydronium ion, H3O plus and Cl minus, okay? So it is termed as acids. And the examples are other examples. In the previous slide, we saw the HCl is an example of acid. And then the next one is sulfuric acid, okay, H2SO4. When it reacts with water, it forms two molecules of H3O plus. As we know that when H3O plus is present, it is an acid, okay, and sulfate ion. And then the next one is nitric acid, that is HNO3. It reacts with water to form H3O plus and nitrate ion. Okay, in this H3O plus is present, so it is an acid. Okay, these are the examples of acid. And then Arrhenius termed the base concept, bases. Okay, as we saw in the previous slide, acids containing H plus and in this bases containing OH minus. OH minus is the only negatively charged ion in the solution. Okay, and the examples are, the first example is NaOH. It dissociates into Na plus and OH minus ion. When OH minus is present, it is a base. Okay, so NaOH is a base, that is sodium hydroxide is a base. And then the second one is calcium hydroxide. The formula is CaOH the whole power twice. It dissociates into Ca2 plus and OH minus ion. In this also OH minus ion is present, so it is a base. And then the third one is magnesium hydroxide, and it dissociates into Mg2 plus ion and OH minus ion. And OH minus ion is present, so it is a base. Okay, and then we term the bases as metallic oxides or hydroxide. Okay, the examples are copper oxide, as we know, NaOH as we saw in the previous slide, and then calcium hydroxide. Okay, now let us see the basic terms. Okay, as we all know that alkalis, don't confuse with the terms alkalis and bases. Okay, and alkalis are special category of bases. Okay, alkalis are also basic hydroxide, and the main criteria is alkalis are soluble in water. Okay, bases are also soluble, and some of the compounds are insoluble in nature, but alkalis are the only substances that are soluble in water. This is a main condition or criteria. Okay, and the example is NaOH. As we all know, NaOH is soluble in water. Okay, it is soluble, so it is definitely an alkali. Okay, and it is also a base. A base may be soluble or insoluble, but an alkali must be soluble. So NaOH is a base and an alkali. And then the next one is iron hydroxide or ferric hydroxide. FeOH the whole power thrice is insoluble in water. So it is not an alkali, but it is a base. Okay, when we dissociate, it forms OH minus ion. Okay, so it is a base, it is not an alkali. Okay, from this example we can conclude that all alkalis are bases. Okay, alkalis means soluble substances or bases, but all bases are not alkalis. Okay, bases will which contain the insoluble and soluble substances. So all bases are not alkalis. This is a main important thing you will understand while seeing this example. Okay, go through this example. And then the next one is classification of acids. Acids are two types, that is strong acid, weak acid. Okay, let's see in detail. First one is strong acid. Strong acid means It ionizes completely. This is the main important thing. It ionizes completely to produce high concentration of H plus or hydronium ion. As we know, H plus didn't exist, so hydronium ion is very stable. Okay, as we all know. The example is HCl, H2SO4, HNO3. HCl dissociates with water as H3O plus and Cl minus, so it is a strong base. And H2SO4 also dissociates and give H3O plus. Two molecules of H3O plus and SO4 2 minus. And HNO3 also dissociates in water to give H3O plus and NO32 minus ion. Okay, as we already saw them in the first acids category. Okay, go through the acid categories. Okay, the main important thing is strong acids are completely ionized to produce a high concentration of H3O plus ions or H plus ions. And the next one is weak acids. Okay, weak acids means it partially ionizes and produces a less concentration of H3O plus ion. Okay, the examples are, okay, see this acetic acid is a weak acid. The example, okay, it dissociates in water to form H3O plus and acetate ion. In this, H3O plus is in less concentration. Okay, so it is termed as weak acids. The other one is H2CO3. It also dissociates in water to form less concentration of H3O plus and CO3 2 minus ions. Okay. And now we are going to classify the bases. Bases are also divided them into two, that is strong bases and weak bases. Let's see them in detail. The first one is strong bases. Strong bases means ionizes completely ionizes and produce a high concentration of OH minus ion or hydroxide ion. Okay, and the example is NaOH. As we already know, NaOH dissociates into Na plus and OH minus ion. And then KOH. KOH also dissociates into K plus and OH minus ion. Okay, the next one is weak bases. Okay, weak bases. Weak bases are partially ionized to produce a less concentration of OH minus ion. Let's see the example. The first example is ammonium hydroxide. Okay, ammonium hydroxide dissociates into NH4 plus and OH minus ion, that is hydroxide ion. The concentration of hydroxide ion is less in ammonium hydroxide. Okay, and then the next one is calcium hydroxide. Calcium hydroxide dissociates into Ca2 plus and hydroxide ion. Okay, if you notice, these two are reversible in nature. Okay, okay, let us sum up what we see in the previous slides. Okay, according to Arrhenius equation, acids or which produces H plus or hydronium ion, that is H3O plus ions present. Okay, and then acids are divided into two types, as we know, strong acids and weak acids. Strong acids are the ones which completely ionizes and produce a high concentration of H plus ion. The examples of strong acids are HCl, H2SO4, HNO3, etc. And then weak acids which partially ionizes and produce a less concentration of H plus ion. The examples are acetic acid. Okay, and then bases means OH minus ions are present in the solution. Okay, and it also divided into two types, that is strong bases and weak bases. Okay, strong bases means um, it ionizes completely and produce high concentration of OH minus ion. And then weak bases means it partially ionizes and produce a less concentration of OH minus ion. The examples of strong bases are NaOH, KOH, that is sodium hydroxide and potassium hydroxide. And then the weak bases, the examples are ammonium hydroxide. Okay. Okay, now let us see the neutralization reaction. Okay. What is neutralization reaction? When an acid and a base react, it produces salt and water. Okay. This is a basic thing in neutralization. Let's see examples. When HCl, as we know, it's a strong acid and it's basically an acid, and NaOH is a base. Okay. It react to form NaCl and water. NaCl is a salt and water. Okay. And then nitric acid react with KOH to form potassium nitrate is a salt and water. This is a neutralization reaction. Okay, now let us see the basicity of acids. As we know, acids are which ionizes completely or partially to produce H plus or H3O plus ions. Okay, let's see the basicity of acids for different acids. Okay, the first acid is hydrochloric acid. When we react with water, it forms ions. Okay, in aqueous solution, it forms ions. That is H plus and it dissociates into H plus and Cl minus ion. Okay, in this, one H plus ion is there. Okay, we have to add one OH minus ion to neutralize it. So one base is needed. So it is monobasic. And then nitric acid. It dissociates into H plus and NO3 minus. In this, only one H plus is present. So we have to add only one OH minus ion to neutralize it. So monobasic. And then ethanoic acid or acetic acid. Acetic acid dissociates into H plus and CH3CO minus. Only one H plus is present and we have to add only one OH minus ion to neutralize it. That is neutralization reaction. So we have to add one OH minus. So it is monobasic. See this H2SO4. It dissociates into two molecules of H plus and sulfate ion. Two molecules of H plus is present. So we have to add two OH minus ions to neutralize it. So it is dibasic. And then for phosphoric acid, it dissociates into 3H plus and phosphate ion. 3H plus is present in phosphoric acid. So we have to add 3 OH minus ions to neutralize it. So it is tribasic. Okay. And okay, now we are going to see the acidity of bases. As we already saw the basicity of acids in the previous slide, now we are going to see the acidity of bases. Okay. The first example is NaOH and the second one is KOH and third one is NH4OH. All these are dissociate to give Na plus and OH minus, K plus and OH minus, NH4 plus and OH minus. Okay. In these three, only one OH minus ion is present. Okay, we have to add one H plus ion to neutralize these. Okay, so only one H plus ions we have to add. So it is a monoacidic base. Okay, and then the second one is calcium hydroxide and barium hydroxide. In this, two OH minus ion is present. See this two. So we have to add two H plus ions in this. So it is diacidic base. And then the third one is AlOH the whole bar, aluminium hydroxide. In this, 3 OH minus ion is present. So we have to add 3 H plus ions to neutralize it. So it is triacidic base. Okay, clear? Okay, now it's a question time. Okay. Okay, what happens when a bee bites in your hand is a question. Okay. When a bee bites, it ejects an acid in your hand. You have to know A B string contains an acid. Okay, the basic first aid is you have to rub it with a soap because the soap is a base. Okay, the chemistry behind all these first aid is neutralization reaction. Neutralization reaction means when an acid and a base reacts, it gives salt and water. Okay, this is the chemistry behind a bee bites or a bee sting. Okay, and thank you for watching. If you have any doubts, put it in comment box. We will surely help you out. And thank you.